Okay, so hello everyone. Our final project was prediction of house prices, and we are the robot squad.
Hi, I'm Sneha.
I'm Kate.
I'm Juan.
I'm Jay-Z.
My name is Santiago.
And I'm Aidan.
I'm Kate.
Sorry, I was on mute. Okay, so during the first week, we gathered 2 data sets of house prices in Washington State from the data website Kaggle.com. And our goal was to create a basic system that can predict a house price based on input given by any user. And this input included things such as the number of floors, rooms, square feet, and a couple more variables. And here are the following steps we took to reach our goal. The first step was to analyze and clean our data sets. And after that, we visualized and merged the data sets through graphs. And then we applied the 3 models to achieve the greatest percentage of matching. And then after that, we started the website building. And another thing I just wanted to add is the why of why we made this product is to help people look to buy or sell, to help people who are looking to buy or sell a home, or people who are looking to find their dream home with their dream price. And then continuing on, we our first step was to import the data. And as you can see, we started off by importing these files into our model to access the data from other files, such as the data set we used. And then that puts it into our model. And then after that, we loaded the data, and then this transfers the files of data into code. So as you can see in the table, like chart below, you can see that our data is just the first couple variables in it. You can totally tell how it's turning into data. Kind of, sorry, that was kind of a bad explanation, but you get the point.
All right, this is our data visualization. Here are some graphs that we made. And the first one is a heat map where I kind of use this one to see what correlates with the price the most, like the square feet living, etc. The second one is a scatter plot, and this one measured the relation of the price with square feet living, just like I said, and also the condition. The third one is another scatter plot, and this is just the square feet above the price and the cities. And the next are box plots, and I just kind of use these to see. I mostly use the price in the city. It was interesting to see how one city is a little more pricier than the other one. And yeah.
We also used bubble charts to see the correlation between square foot of living price, the price of the number of bedrooms, and what we used for the actual bubbles is whatever town in Washington we're trying to see the price of. And we also used linear regression with polynomial features where we compared price to basically every factor we could use, and that gave us our second highest score of 79%.
Now we just to use the decision tree that is putting questions to lead to another more questions to get a final result. And it gets our lowest value of accuracy because trying to get all this to work perfectly without any errors, it's a little complicated, but it's still high with 69%. And we got the neural network that is distributed in layers and is to teach the machine the process. So it will take all the errors and the success it has in all the process to get the better result. And it got the highest accuracy with 81%.
In conclusion, our team was successful in making a product that could determine the house prices in Washington using factors such as living space and number of bedrooms. We also were successful in making data models such as the box plot and bubble chart that most effectively showed our data. And now we'll move on to the website. Here we have our home screen, which tells about our AI and why we decided to make it. Here's our data visualizations, with our heat map showing the correlation between all the variables, scatter plot showing the price between square feet and price, blocks plot showing how the grade affects prices, a bubble chart showing the price in square feet of living for each city, box plot showing how the cities affect the prices. Now for our data models, we used linear regression, the decision tree, and neural networks, which we got our highest score of 81%. Now Sneha will show us the actual product.
Yeah, Sneha will gonna to show us the Flask version.
So the other one was the static website. And this one is a conclusion page that actually shows us the Flask. So we used our neural network, which was our best model to make a house price prediction based on our data set. So I'm gonna put in dummy numbers so we can see how this works. So based on the factors, we can have the estimated living price down here. So on the bottom is the About Our Team page. And while I showed this, I wanted to talk about some of the limitations of our project. So one of our limitations is that our data set is based solely on the state of Washington. So we would love to expand it to more locations. Another limitation is that the data ends around 2014 to 2015. So we weren't able to take inflation into account with more recent data. Thank you for listening to our presentation.